Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 17, 2025, about 4 days ago. The headline result is that likelihood-based training can fail when demonstrations only prove correctness, and a new method instead learns with sample complexity that scales logarithmically with the size of the reward class. The paper is titled, Learning to Answer from Correct Demonstrations, and as we'll see, the implications for model training are quite significant. Beyond the core theory, the authors give an online algorithm with at most log base, 2 mistakes in the reward class size, and extend it to pass at k outputs with minimax optimal guarantees. The previous overview set up why modeling correctness matters. Table 1 compares maximum likelihood estimation against the proposed learner across 2 assumptions. Under a low-cardinality policy class, both achieve error that scales with the log of the policy class size. Under a low-cardinality reward class, maximum likelihood estimation may not learn at all, while the proposed learner achieves error that scales with the log of the reward class size, which is the key takeaway. Alright, the previous figure contrasted assumptions for training. Figure 1 describes the online mistake unaware setup, which captures how learning proceeds when feedback only shows a correct demonstration. The learner first receives a context, then outputs a response. A mistake occurs if the response falls outside the sigma star set, the set of acceptable answers, but the learner does not know that. Finally, the learner receives one correct answer as a demonstration. This timing matters because supervision arrives regardless of the learner's choice. Well, the previous figure introduced the timing of feedback. Figure 2 illustrates how the learner updates weights over reward models using a 3-region rule. The left circle marks models that would accept the learner's prediction, and those weights drop to 0 because the demonstration contradicted that prediction. The right circle marks models that accept the demonstrated answer, and those weights double. The small overlap marks models that accept both answers, and those weights remain unchanged, which preserves hypotheses consistent with both signals. Alright, 2 takeaways stand out. Likelihood-based training can mislearn when demonstrations only certify correctness, and reward class-aware algorithms achieve error that shrinks with the log of the reward class size, including strong pass at k guarantees. The broader implication is a shift toward modeling correctness sets, not demonstrator distributions. That is it for the AI Research Roundup. I am Alex. Thanks for listening.